Microamps is primarily an HVAC function. You don't see too many electricians using microamps. To give you an idea what a microamp is, it is 1/1000th of an amp. Now, a 120 watt light bulb on 120 volts draws 1 amp of current. So 1/1000th of an amp is not very much current, very sensitive a piece of equipment to measure that. How it's used is on furnaces. So here's a furnace that has a flame sensor rod. That's what I'm touching right here. That rod sits in the flame that's generated from the furnace. So the way things work is actually an AC signal is applied to the flame, and when the flame touches that rod, current will flow through the wire. Now, flame is not very conductive. It's not like copper wire, so it has a lot of resistance, and it takes a lot for that voltage to get through the flame. So you only have microamps of current flowing through. Even though it's an AC signal that's applied to the flame kind of rectifies it, and it ends up being a DC signal. So when we measure microamps, you primarily want to look at microamps as a DC function. So the way we measure microamps is we you notice that this probe here comes up to a wire which goes to the sensor. So we have to put our meter in series with that wire. So we disconnect that from the tab. Let's clip on our negative probe there. Put our positive probe inside this terminal lug. We've got our meter set to the microamp, the test probes plugged into microamps. So we'll turn on microamps here, select DC current. Right now there is no current being drawn because there is no flame. So let's turn on the furnace. It's going to take a few seconds here for the pilot to ignite, but once the pilot ignites, let's turn the light on to this guy too, so you can see the display better. So our hot surface igniter just turned on. It'll be heating up very shortly. Once that heats up, gas will flow through. Once the gas flows through, we'll have flame hit that flame sensor. And there's our flame. And you can see we have 1 microamps of DC current flowing through that flame sensor. That's enough for the controls to sense that flame is there and keep the flame on. If I were to remove this wire, the control would say, hey, there's no current flowing through, and it's going to shut off the gas.